This video is an add-on to the STL and Grieber files I provide on Cults 3D for making a pinball kickout hole. Jump to the part you like to watch. Part 1. Building the assembly. Prepare your copper wire and 2 connecting wires. I usually use green and yellow for the coil connecting wires. The copper wire should have a diameter of 0.1 mm, which is 0.004 inches. Strip some of the insulation from the connection wire. Wrap the copper wire around the connecting wire and solder them together. Make sure you use enough heat and time to melt the insulation of the copper wire. Mark the corners of the wire guide with a waterproof pen, which increases the contrast. The copper wire must be routed around the corners, otherwise it will tear off when the kickout hole is installed. Now glue the connecting wire into the groove. This works best with a light-activated glue. Wrap the copper wire around the body 30 times. Here too, the wire must remain in the groove. When all 30 turns have been laid, fix the copper wire with a little glue just before the groove for the second connection wire. Solder the copper wire to the second connection wire. The connection wire must fit into the groove without the copper wire being stretched or too long. This works best if you place the connecting wire over the first one and leave the insulation about 5 mm above the body. Glue the connecting wire into the groove. Again, make sure that the copper wire is completely in the groove. Apply a layer of glue over the copper wire windings. Now the coil needs to be checked. Use an inductance meter for this. Without a steel ball, the coil should have around 70 microhenry. With a steel ball placed, around 5 microhenry more. I recommend installing an indicator LED. It always lights up when the sensor detects the steel ball. This helps a lot when finding and fixing errors. For this I always use white and blue connecting wires and a red 3mm LED. Solder the connecting wires to the LED and insulate the wires and soldering points of the LED with shrink tubing. Glue the LED into the hole provided. If necessary, glue the connecting wires of the coil at the bottom with extra glue. In case you are printing a transparent body and you want to illuminate it, prepare a 5mm LED in the color of your choice. Cut the connecting wires of the 5mm LED relatively short. The soldered connecting wires must later be able to be pulled through the slot in the body. Insulate the connecting wires and solder joint with shrink tubing. Glue the 5mm LED into the hole provided. Pull the connecting wires completely through the long hole in the body. Check both LEDs, don't forget to use an appropriate series resistor. Remove the nut from the solenoid axle. Deburr the hole in the pushrod and screw the pushrod onto the axis of the solenoid. Use a screwdriver to secure the axle. Put the solenoid in place. Make sure the pushrod is inserted into the square hole in the correct position. Screw the solenoid loosely onto the body. The position of the pushrod can be adjusted by sliding the solenoid up and down. Use a steel ball to check the installation depth of the pushrod, adjust if necessary. The mounting bracket must be attached to the body in the correct orientation. There is a small groove in the body for this purpose. The screws must be screwed into exactly this groove. I'm marking it here. Before fixing the mounting bracket to the body, check its alignment again. Attach the thermostatic switch to the solenoid coil with a cable tie. Be sure to use thermal paste. Make sure no wires are pinched between the cable tie and the body. Check the finished kickout hole assembly visually. Everything is okay here and the next step can be taken. Part 2. Electronic circuit testing. Connect the power supply. Press the onboard test button. The onboard LED must light up briefly, much shorter than the button is pressed. If the LED does not light up or only lights up weakly, then turn the potentiometer several turns counterclockwise. The LED must light up briefly but brightly. Connect the solenoid to the SOL terminals. Press the test button. The solenoid must not be activated. Put 5 volt to terminal K-I. Here too, the solenoid must not be activated. Now connect the thermostatic switch to the terminals TS. Press the test button. The solenoid must be activated briefly, regardless of how long the button remains pressed. Put again 5 volt to terminal K-I. Here too, the solenoid must be activated very shortly independent how long you put the 5 volt to the terminal. Press the solenoid with the nut against the table and press the test button. Every time the button is pressed or 5 volt are put to K-I terminal, you should hear a beep, which shows that the power control is working. This circuit board works and can be used. Part 3. Preparing the playfield. Draw a cross on the desired position of the kick-out hole on the playfield. Position the milling template exactly on the cross. Use the viewing slots on the template to do this. Screw the template onto the playfield. Now mill out the hole. To do this, use the provided router guide sleeve and a 4 mm milling head. Sand the edges of the milled hole. To close the screw holes, insert short pieces of wood, for example hardwood toothpicks, into the holes, hammer them slightly in and shorten them just above the surface. Then simply sand it with sandpaper. Turn the playfield. Check whether the mounting bracket is correctly mounted on the body. The screw and the line marked here must be on the same level. Also mount the mounting bracket at the very top of the body. Wrap 2 layers of electrical tape around the body. This will help center the kickout assembly in the hole. Mark the mounting holes on the playfield. Drill 2 mm holes for the screws and screw the bracket onto the playfield. Loosen the screws that attach the body to the mounting bracket. Now adjust the installation depth of the kick-out hole. The best way to determine this is to feel it with your fingers. When the desired installation depth has been set, screw the mounting bracket screws back into the body. Remove the kick-out hole assembly. Take off the electrical tape and reinstall the assembly on the playfield. Turn the playfield. Check that the installation depth is correct and that the push rod moves up and down without friction. With the kickout assembly on Cults 3D, I also provide the demo code shown here. Also included is the wiring plan. The following circuit boards are required here: 1 Arduino Mega, 1 lamp driver board, 1 inductive sensor board and 1 kickout hole board. I make the lamp driver board and the inductive sensor board available on Cults 3D under Pinball Inductive Sensors and Lamps. After powering on, check if the knockout hole LED is flashing slowly. Push a ball into the kickout hole. The LED should lit steadily for 1 second. Then the LED should flash fast for 1 second, after it you should hear a beep. To adjust the force with which the ball is ejected, turn the potentiometer clockwise for less force and counterclockwise for more force. Here less force is adjusted. A greater force is set here. Thanks for watching.